This is our Magnetism Project for AP Physics 4th period. I am Luke Johnson along with Joe Sullivan and Luke Ramadi. We're going to start off by talking about the basics of magnetism, and then we're going to be expanding the use of magnetism to specifically talk about how electric motors work. Now this first video is just going to be showing how we use magnets in class, whether or not one magnet or two magnets test how certain things were attracted to either the North Pole or the South Pole and how they were repelled. So you can see how using this, it was north-south and then north-south, so the North and the South Poles are being attracted to each other, so there's no resistance. And as you lay down the shavings, you can see the pattern of the electromagnetic field.
Under the sheet of paper there are two magnets, the first one facing south-north, and then the second one is also facing south-north, which means that the two magnets are attracted to each other. And the shavings represent the field lines, which run from north to south.
Now continuing on with the same project, we have changed the poles so that north and north are facing to each other and so that there is a repulsion between them. So you can see how whenever we push down the north magnet, it pops back up. So we're looking it down, and eventually we're going to move it back and take down the north pole so that it stays better.
Alright, well, so as you guys know, magnets produce magnetic fields. Magnetic fields run from North Pole to South Pole. And in this situation, the magnetic field on the left is running from the red side of this magnet to the white side, and on the right is doing the same thing. So the magnetic fields are repelling. So that the force that exerts on any metal object is going to be tangent to the magnetic field lines. Alright, so when we demonstrate the effect of a magnetic field, we're going to put iron filings on a piece of paper that's over this two magnets, and the iron filings are going to fan out from the center because that's where the magnetic field is being originated, and then it stops or terminates at the south poles.
Now putting the lead shavings down on here so you can see how they're repulsed or they're attracted to the North Pole or the South Pole. Now that the poles are facing each other and have the same poles and they're acting out, you can see how the pattern for the shavings has changed so that more are being spread out and they're avoiding the area where the two poles are closer together and therefore creating a magnetic field that's pushing out. Now we're going to start talking about how magnetic fields are used to move things in an electric motor, either a fan or any other thing that uses electric motors. So we're going to start off by showing you this picture of an old-fashioned electric motor. This is one of the first motors made, and you can see the wires running across, and it has the two bars. So the wires are creating a magnetic field as charges are moving through the wire, because a magnetic field is created by a moving charge. So as that magnetic field is created, it's moving the bar around, causing wind. So that would be one of the first examples of an electric motor used to create a fan. Now, as I just said, a fan is one of the modern examples of how magnetism is used in an electric motor to cause rotation. So the blades are attached to the motor, which is inside the plastic casing, and inside that electricity is running through, causing a magnetic field to move the motor in rotation, which is causing the blades to move.
Electric motors are powered by magnets, and the motor uses the magnets to create motion. Everybody knows opposite poles attract and similar poles repel. So with the two bar magnets in this video, with their ends marked north and south, the north ends of one magnet will attract the south ends of the other. On the other hand, the north end of one magnet will repel the north end of the other magnet, and the south will repel the other south. Inside an electric motor, these attracting and repelling forces create something called rotational motion.
Alright, this is a diagram of a fan. It has a 120 volt voltage source and creates current across the entire system. It comes to the first item in this diagram, which is the switch. It has three options. First option corresponds to the lowest speed of your fan. The third option corresponds to the highest. Each option creates a different amount of current that runs to the rotor, where a higher amount of current will create a bigger electric field and a smaller electric current will create a smaller amount of current will create a smaller electric field. So, as the higher the higher you spin the dial on your fan, the faster it gets.
So using what Joe just explained in the diagram of how when the switch is switched to a different setting, how the current running across the rotor changes, so the magnetic field is larger. You can see how we have this plugged into the wall, so it's running it to the fan, which is then going up to the motor. So that's giving power to the voltage source, which is making the fan move.